In this video, we continue looking at our common toxic materials by moving on to the nitrogen oxide containing gases. And so in this class of toxins, we have two primary culprits. There's the nitric oxide. Nitric oxide is a colorless, odorless gas, formula NO. And then we have nitrogen dioxide, NO2. Which is a reddish to brown gas, and it has a very sharp, pungent kind of odor to it. It is the nitrogen dioxide that is classified as one of the major air pollutants, and is what gives smog its characteristic kind of brown haze in color. Now, where does it come from? Well, most of the NOx gases that we have come from two primary sources. One of them is transportation. So about half of the NOx in our air comes from transportation activities, people driving cars, people, our interstate shipping, all of that kind of stuff. The other half essentially is from fuel combustion activity. So the burning of different types of fuels to create different types of processes, and whether it be electricity or heating one's home, or any number of things. The remaining 5% or so come from industry, and just from kind of everything else. But the majority of the NOx gases that we have come from the transportation and fuel combustion kinds of processes. Now, the primary hazards associated with these, obviously, since they are gases, inhalation toxicity is going to be the biggest culprit and the biggest thing that you have to watch out for. The other big issue that we run in with nitric oxide and nitrous oxide is they react with the air. So most of the time we have water vapor in our air, and when these substances react with the moisture in the air, they can produce a combination of acids. The most common acids that they make are nitric acid and nitrous acid. Nitric acid is a common strong acid found in a lot of laboratories, HNO3. Nitrous acid is less common, but in a lot of ways equally irritating, HNO2. And so these, because they tend to stay low in the atmosphere, these tend to just be, hurting kinds of gases, things that irritate your respiratory system, as opposed to, we talked about the sulfur containing gases in a previous video, where we saw that the sulfur compounds react with water up in the upper atmosphere and actually fall back down as acid rain. This really doesn't happen as much with the nitrogen oxides. They tend to stay pretty low to the ground, and are just more respiratory irritants than anything else. Now, how do we get them in combustion processes, in transportation? 95% of our processes for getting nitric oxide, nitrogen dioxide, come as a result of incomplete and complete combustion. So as our oxygen is coming depleted, it may not have enough energy. It starts to react with some of the nitrogen in the air starts to react with some of the oxygen and the nitrogen in the air instead of with the combustible product. And we get these nitrogen containing oxides as a result. Now, for nitric oxide, in low doses, nitric oxide actually does have some potential health benefits. When it is mixed with oxygen and administered to respiratory patients, it actually can reduce inflammation. It'll work inside your blood vessels and actually regulate your dilation. It'll open them up slightly, and allow better blood flow. We also see nitric oxide used in aerospace industry to oxidize rocket fuels. Now, again, the big difference, nitric oxide, NO, is different from nitrous oxide. which is N2O. Nitrous oxide, N2O, also better known as laughing gas. This is the stuff. This is the stuff that is used in like dentist's office and other kind of places as a potential uh, alternative to Novocaine or as a popular anesthesia kind of tool. These are different from each other. Nitrous oxide tends not to have a whole lot that is associated with it in terms of risk, other than in higher concentrations, it can give you some, potentially bad symptoms. Nitric oxide, very, very different. And so, important distinction to make there. Most of the time, when people think about nitrous or think about nitrogen oxides, it's this that they're thinking of, and that's the stuff that is different and relatively benign. Um, this is not the stuff that makes your car go fast. This isn't your Fast and Furious kind of material here. Now, in lower atmospheres, nitric oxide is linked with the production of ground level ozone. And so what happens is that these gases will start to split oxygen molecules from each other. And as the oxygen molecules split, they'll reattach to each other and will end up going from oxygen, O2, to ozone, O3, in these processes. Ozone is pretty nasty stuff on its own. It is a heavy irritant. It in low concentrations, it has an odor. You probably recognize it kind of as that odor. If you have like electronic engines that burn for too long, and they start to get kind of a smell, or that smell that you might get when you've got an electrical circuit and it sparks, or just kind of that smell of electrical power. That's ozone. And so nitric oxide does cause that to increase on lower level, and in low concentrations like those situations I described, it really doesn't bother you. But in higher concentrations where we get ground level ozone, which is another air pollutant, it can be really, really irritating. Now, if high enough concentrations of nitric oxide and nitrogen dioxide are put into your body system, they can actually bond with your hemoglobin and form methemoglobin. And methemoglobin is a hemoglobin inhibitor, and will make it difficult for the hemoglobin to do its actual job of transporting oxygen to the rest of your body systems. So if you get a high enough concentration of it, it is going to be a little bit more difficult for your body to work with it and process it. And it can eventually lead to some pretty nasty effects as far as oxygen transport is concerned. You can get into anoxia or other kinds of asphyxiation kinds of effects. As mentioned before, it is a product of complete and incomplete combustion, and one of the primary places where we can get it is if there are nitrogenous materials in the things that are burning. You can get them that way. So a lot of polyurethane, plastic products, foams. These are constant and potential sources of nitrogen that can lead to these kinds of byproducts. And so that closes the book for us on the nitrous oxides. In the next video, I will talk about two more. We'll look at ammonia, and we'll look at carcinogens and some metallic compounds as well.